Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how we use the Business Analyst BA2 Plus calculator to do our various calculations for a simple annuity due. A simple annuity due has the payment at the beginning of the interval, so the beginning of the month or the year. And the other condition is that the number of payments per year is equal to the number of compound periods per year. The default setting for annuities on the BA2 Plus calculator is actually for the end of the interval, which works for ordinary annuities, but will not work for annuities due. So before we can proceed with these annuity due questions, we're going to have to change our settings to the beginning of the interval. The way that you do that is second function and payment. So second function and payment, and then second function set. So second function enter, above the enter is the set, and you'll see BGN appear on the display. So that's now telling you that this will work for annuities where the payment is at the beginning. Let's clear our display and we're ready to go. We're going to take a look at a variety of examples, and we're going to calculate for different values on our time value money functions. So let's first of all start by getting the information down, and then I'll show you how you enter it into your calculator. Our first example says at the beginning of each month, Amara invests $500 in a portfolio earning 5.5% compounded monthly. So the compound periods per year are 12, and she's putting money in each month. That's 12. Those are equal. It's the beginning, so we know it's a simple annuity due. If Amara contributes for 20 years, what will be the total value of the investment in 20 years? So N will be 12 times a year for 20 years, which is equal to 240. The interest per year, we leave it as a percent, is 5.5. Present value, there's nothing in the account before she starts investing. There's no mention of that, so that's going to be 0. Then her payments are $500. She is putting that money in, so it's coming out of her pocket into that investment. So we're going to make that a negative 500. And we want to calculate future value. Before I start doing these calculations on my calculator, I like to ensure that any previous work is cleared. So if you take a look above the future value function, it says CLR for clear, TVM, time value money. So we're going to clear that. And we're going to start with the number of payments per year and the number of compound periods per year. If you look above the I per Y, you'll see P per Y. So second function P per Y. It's already set at 12. We don't need to adjust it. If you scroll up or down, you'll see compound periods per year. It's 12. We're good. So we can get out of here. Second, quit. And now we can enter these values. The way that you enter these values is you put the number and then the function. So N is 240. So we put 240 in and then press N. Interest is 5.5, so we put 5.5 and then interest per year. Present value is 0. Because we've cleared our time value money calculations from previous work, this will be 0. But if you're not sure, you can always enter a 0. Our payment value is 500. Make it negative with the change sign key. Enter that for payment. And now we'll calculate future value. So compute future value. And the future value is $218,812.01. Before starting our next example, let's clear this and clear the display. Our second example says you want $1 million in an investment at the end of 30 years. How much should your monthly payment be if you make the payments at the beginning of the month and the interest earned is 8% compounded monthly? So compounded monthly, 12 periods per year, and you're making monthly payments, so that's 12 per year. Those are equal, and it's at the beginning of each month, so it is a simple annuity due. N will be 12 times the number of years, which is 30, so 360. The interest is 8%. Present value, there's no mention of money being in there before we start, so that's 0. We want to know the payment, so that we have a future value of $1 million. Let's start with P per Y. It was 12 in our last example, so it should still be 12, but it's always a good idea to check that, and C per Y, and then we can quit. Now we're going to put these values in. 360 is N. 8 is I per Y. Present value is 0. You can either put that in, or if you've cleared the work like I did, it's going to automatically be 0. The future value is $1 million. And we want to compute the payment. So the payment amount says negative. That's because payments are going in. Don't worry about the negative. The payment amounts will be $663.54. Again, let's clear our worksheet and the display before starting the third example. Third example says, what amount will George need in his retirement plan when he retires if he wants to receive $4,000 at the beginning of every month for 25 years if the plan earns 6% compounded monthly? We're dealing with monthly payments and monthly compounding, so I just left those values in. Let's fill in the other values. So N will be 12 times 25 years, which is 300. Interest rate is 6. We're going to be finding the present value, in other words, what George needs at the beginning, in order to receive payments of $4,000 a month. Because George is receiving that money per month, I'm going to leave it positive. If he was investing that money per month, I would make it negative. There's no mention of having any money left over after 25 years, so we will put a 0 in for future value. We already know P per Y and C per Y are 12 from the previous example, but you can always check it just to make sure, and then quit. And now let's plug these numbers in. 300 for N, 6 for I per Y, 4,000 for payment. You can put 0 in for future value, but I know it's already set at 0, so I don't need to. And I want to calculate present value. So present value is going to be $623,931.59. Notice that there's a negative. That just means that's the investment that needs to go into his pension plan so that he gets these payments out, but we can ignore that negative. Let's clear our work and clear the display. Our next example says $1,000 is deposited into an annuity at the beginning of each year if the value of the annuity at the end of 3 years is $3,374.62. What interest rate compounded annually was earned? So the payments per year are 1. The compound periods per year is 1. Those are equal, and we're talking about beginning of the interval, so it is a simple annuity due. N will be 1 times a year times 3 years, which is just 3. The interest rate is what we're going to be finding. The present value is 0. There wasn't money before we started putting that $1,000 in. The payment is negative 1,000 per year, and the future value is $3,374.62. So let's start with payment per year. Second function, I per Y, and that gives us payments per year. It's 12. We want it to be a 1. So we press 1 and make sure you enter it. When you scroll, you'll see that compound periods per year also change to 1. We're going to quit that, and now we're going to put these values in. 3N. Present value is 0. We've cleared it, so it's automatically 0. Payment is negative 1,000. Make it negative payment. Future value is $3,374.62. That's future value. And now let's compute interest rate. And we get 6%. Let's clear the display, clear our work, and take a look at the next example. The present value of an annuity is $25,000, and it's earning 9% compounded monthly. If payments of $500 are made at the beginning of each month, how long will it pay before running out of money? So our payments per year are 12. Our compound periods per year are 12. They're equal. It's beginning. It's a simple annuity due. We're going to be finding N. Because we have monthly payments and monthly compounding, N will automatically be in months. Interest rate is 9. Present value is $25,000. Payments are negative 500, and the money's running out, so the future value will be 0. Let's start with payments per year, and let's go back to 12, so 12, enter. Compound periods per year is also 12. We can quit. Let's enter our interest rate. Now let's enter our present value of $25,000. our payments of negative 500, change sign payment, and you can put the 0 in for future value if you choose. I don't need to. All I need to do now is calculate or compute N. So compute N, and we get 62.3 months. If we want to convert that to years, we simply divide by 12. So it'll be 5.2 years. Let's clear our work and clear our display before looking at the last example. This last example is a little bit more complicated. Let's take a look at it. It says when Julia's daughter was born, Julia started making payments of $1,000 at the beginning of every 6 months, so semi-annually, to a trust fund earning 4.75% compounded semi-annually. After 10 years, she changed her contributions and started depositing $1,500 at the beginning of every 6 months. How much money will be in the trust fund when Julia's daughter turns 18? In this situation, because the amount of the payments change, we're going to actually think of this as 2 annuities. In the first 10 years, it's 1 annuity, and then for the last 8 years, it's another annuity. So let's start with the first annuity. Both the payments and the compounding is semi-annually, so both of these values is 2. In the first 10 years, 2 times a year times 10, there will be 20. The interest per year is 4.75%. The present value, when she was born, there wasn't anything in there yet, so that's 0. The payments are negative 1,000 per month, and we want to know the future value. So at the end of that first 10 years, what's the future value of this annuity? So let's start with payments per year. We need to change that to 2, so 2, enter. Compound periods per year is also 2, so we can quit. Let's enter 20 for N, 4.75 for I per Y, 0 for PV or just leave it, negative 1,000 for payment, and now let's calculate future value. At the 10-year mark, this money is sitting in the account, and then the second annuity starts where $1,500 is added every 6 months. So this becomes the present value at the 10-year mark of that annuity. So our next calculation will be over the next 8 years, and we're going to use this value as our present value, change our payment amount, change N, and then recalculate our future value. So N from the time Julia's daughter is 10 to 18 will be 2 times a year for 8 years, which is 16. Our present value will be $25,824.79. That's what was in there from the previous part of the annuity, and we need to make that negative. The payments are now $1,500, so we also make that negative, and we want to find future value. So let's clear this work, clear our display. We already know that P per Y is 2, C per Y is 2. Let's just put these new values in. So 16 is N, 4.75 is I per Y, 25,824.79 negative is present value, 1,500 negative is payment. Now let's calculate future value. So future value will be $67,067.08. So just be aware of how you handle a situation where the payments change. Let's clear it, clear our work. Now notice BGN is still on the display. So even if you turn your calculator off and turn it on again, it's still going to be in that mode. If you return to ordinary annuities, you want the payments at the end of the interval, so you don't want them at the beginning. In order to change back to end, we do the same thing we did to get into beginning. Just go second, PMT, second, enter, and now it's at the end. If we clear that, it doesn't say end on the display. That's because it's the default setting. It'll only show BGN when you change it to BGN. So when you're doing these questions, make sure you're aware whether the payment is at the beginning or the end of the interval, and set your calculator to that time frame as well.